Martin from the Alan Turing Institute is going to be talking to us about the Federated Research Infrastructure by Data Governance extension. If I got that right, Fridge, is that correct?
Yes, that is correct.
All right.
You hear me okay?
Yeah. Take it away.
Yeah. Cool. So I'm going to talk here about sort of their UK funded project called Fridge, which is about federating research infrastructure by sort of data governance extension. And I'm Martin O'Reilly. I'm the Director of Research Engineering at the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence. So there I run the research engineering group. But for the last few years, I've also been leading our work on our own data safe haven, which is a trusted research environment, so a piece of infrastructure where researchers can work safely with sensitive data, and I'll talk a bit more about that for a brief intro for those who don't know it. I've also, myself and others on the project, have helped establish the UK Trusted Research Environment community, which has sort of grown to about 300 people over the last few years. And I co-lead this project that I'm going to sort of talk about today, along with Sadaf and others, on Fridge, which is basically looking to provide this trusted research environment capability on high performance compute clusters, and for this project specifically, the AI research resource clusters. So I'm going to talk a bit about sort of what Fridge is, and then as a brief overview, then sort of what TREs are, and then how why Fridge is needed, sort of how it works, and what we'd like people to do to get involved. So at a high level, like Fridge is a trusted research environment capability for high performance compute clusters, so the ability to isolate projects and with sensitive data and ensure that we're sort of dealing with that safely, while giving researchers access to high performance compute capability, and that sort of achieves this by supporting the extension of a client organization's information governance model onto that high performance compute cluster. So it's a collaboration between the Alan Turing Institute, UCL, the University of Bristol, the University of Cambridge, and it's funded by DARE UK as part of their sort of transformation program. So I'm going to briefly touch on what trusted research environments are, so that everyone's sort of in the same starting place. And talk about why we need TREs, what TREs are, and how they work. So why do we need a trusted research environment? Well, what we really want to do is do effective research on sensitive data, but people are concerned, and rightly so, that that data is protected and is only used for the sort of purposes it's been given permission for, and only the people who've been allowed to access it can do so. So we need to ensure that we're keeping that data safe, and we're doing that in order to maintain that societal consent and public confidence, and also avoid breaching any sort of legislative sort of rules around how we handle this data. And what are these environments? Well, there are highly secure computational analysis environments that allow approved researchers to carry out approved research using sensitive data. And the way they work in almost all cases is by implementing some combination of what's called the 5 safe controls. So I'll talk, and these have sort of heavily informed how ONS sort of go about sort of their work with trusted environments, and also how the NHS and the health ecosystem sort of goes about that. So they originally came out of the national statistics world. So these 5 safes are safe projects. So the research itself is approved either directly by sort of consent, or via data custodians where that's secondary use. Research is done by safe people. Researchers are trained and authorized to access the data. Research happens in a safe setting. There's a sort of environmental controls that control data access and help people do the right thing. The data that we use for the research is safe, and this is about only using data that we need, not having data that's unnecessarily risky or sort of private if we don't need it for the research. But generally, this is what we call a residual control. It's the last lever you want to pull. You want to pull down hard on all the other levers, and then do just enough that you have to sort of do with the data in order to make it safe, because you're going to put that in a safe environment for an approved purpose with safe people. And the goal is, you want that to be able to carry out that research. And then finally, safe outputs. So once you've done the research, once you move it out of the secure environment, the safe setting, how do you make sure that those results aren't disclosive? And when we think about where a TRE fits in this, it's very easy to go, well, it's the safe setting, it's the secure environment because it's technology, right? But actually, a TRE includes the whole thing. You can't. The technology is a tool to sort of run the information governance that makes these 5 safes kind of an integrated set of protections to allow researchers to work productively but safely with sensitive data. And we can split these up into sort of governance around the approval of projects and people, technical, the kind of TREs themselves as a software or a computer system, and then maybe this is a mix of governance and statistics, but making the data safe and making the output safe. So why do we need Fridge? How does Fridge work? How can you get involved? So Fridge is needed primarily because these high-performance compute clusters generally don't support the level of isolation between projects and their data that's required, for projects that are sensitive enough to require a TRE. And TREs, trusted research environments, generally don't include these large-scale high-performance compute capabilities as part of them because they support a wide range of work and most of it doesn't need it. And this one's not about the technology. It's very difficult to establish trust between 2 systems and 2 organizations, even when both of those systems are trusted research environments. People have different information governance regimes, different sets of controls and requirements, and it's very, very difficult to kind of work out what equivalence looks like, get a data custodian or comfortable that the data can move to another environment. And you generally have to do that for every combination of systems or organizations. And there's some great work going on in the main DARE project to extend Sartre, which is a standard architecture for TREs that's trying to kind of come up with some standards that are currently quite high level, but to say what does equivalence look like. But currently this is a really thorny problem and one that's very, very rarely cracked. So, how does Fridge work? How are we tackling this problem? Well, what we're doing is putting information governance, this gnarly problem, front and center. And we're taking the approach of saying, what would it take to extend the client organization's information governance model to the HPC cluster? So rather than say, I trust the HPC cluster's governance separately and independently, as an organization, what do I need to be comfortable that I can have a portion of that cluster at least fall inside my information governance control? And the way we sort of, the inspiration for this is sort of a couple of us, Turing's Data Safe Haven, the UCL's Trusted Research Environment. They deploy onto the Azure and AWS clouds respectively. And we rely on this model at the moment, this shared responsibility model. So the cloud provider provides us with some guarantees and promises around if we configure their environment a certain way, resources will be strongly isolated. Then we can treat them for all intents and purposes as if they're different computers or different networks, but obviously virtual ones. And we can choose to rely on them for that. And then it's on us to configure that properly and to do all the other things around the 5 safes to ensure that our governance model is working and that we are protecting that data effectively. And in terms of technically how we're sort of going about that, we're looking to decompose this problem into things that can be sort of replicated independently by the parts of the composite system. So on the high performance compute side of things, we're looking to have an API for the client organization to be able to configure a strongly isolated segment of that high performance compute system as a secure TRE tenancy. And then we're going to look for that TRE tenancy to support the common infrastructure layer. So what we're currently targeting is a Kubernetes compatible container service, but we can, if you've got something different at your HPC cluster, we're happy to talk about that. And then we're going to have a common set of code to reproducibly deploy TRE components, and these will target that common infrastructure. And so the security is provided by the tenancy and how we configure that. And within that, we can put the services that we would otherwise deploy inside our home TRE into this remote TRE. This, I talked about Sartre, which is one of the strands of the central DARE core components program. But another component is around sort of what does what does a sort of reference architecture look like for reusably deploying and composing components of TREs and sort of what does federation in general look like? How do you combine two TREs together? And we see a lot of overlap there, and then we'll be working closely with those other projects. And then this last bit is really, really important and isn't technological. It's standardizing a shared responsibility sort of TRE tenancy hosting agreement so that we can say, okay, here are the things that the high performance compute cluster is responsible for. That means we can be confident that we're able to configure a sufficiently isolated segment of the machine as a TRE tenancy. And where possible, we're going to look to leverage existing security standards such as the National Health Services Data Security Protection Toolkit, the cyber assessment framework from the NCSC, the National Cyber Security Centre, and ISO 27001 sort of standards. And there's two sort of approaches that we're looking at, and we may end up implementing one or both of these. So the first one is to deploy a standalone trusted research environment into that HPC, high performance compute sort of segment that's been secured as a secure isolated TRE tenancy. And there we would sort of replicate everything we'd have in our home trusted research environment. And the other option we're looking at is to extend an existing trusted research environment. So we would have the researchers' project set up at home, or in our case on the cloud, in our trusted research environment with all of those controls, and we'll allow that project trusted research environment to be able to configure and set up a satellite segment inside the high performance compute tenancy. And there we would not need to deploy all of the capabilities that we've got in the home trusted research environment, just those that we need in order to leverage the large scale high performance compute services. And in the case of AIR, the AI research resource, those are sort of cutting edge graphical processing units, accelerators that let us train large AI models. And critically, for us, success for this project is putting one of our actual health projects that works for sensitive data, configuring a fridge TRE on one of the AIR platforms and running a large scale sort of training job. So we really want to be moving data across these organizational boundaries because we figured out the problem both technically and from a process and policy and a legal agreement perspective to treat that portion of the computer, that high performance cluster, as under our control for the period that we're using it. And while this is a short project for 1 year with a small number of people funded, we're going to be focusing quite ruthlessly on getting this first production research, sensitive research load on. We're very keen to do that in a way that makes it maximally reusable for other people. And so if we've got choices about how we implement something, we want to know that these are choices that will help that be supported elsewhere. So the key conversations we'd love to have with folks in this room and elsewhere is if you're a data provider worried about the safety of the data that you're looking after, or you're an administrator for an existing research environment, what would make you comfortable to extend your existing information governance to one of these secure, isolated segments of a high-performance compute cluster, these TRE tenancies? And if you are a high-performance compute administrator, can you support this tenancy model? Can you say this, at least for a period, this part of the computer is very strongly isolated and all the data that's in there can only be accessed by a certain set of people? And if you can, what technically and procedurally, what are the ways you'd go about that so that we can kind of make sure we're exploring all the options and that we can, look to factor things out so that there's a minimum amount of additional work required to support a different type of high performance compute infrastructure or a slightly different, type of information governance. So if you want to get in touch, we don't yet have a project website because there's doing the official launch next week. So it's not published yet, but you can email me at moreilly@turing.ac.uk. If you want to get more involved in the TRE community in general and be involved in these conversations of how do we sort of share the burden of doing some of this work and find solutions that work once and for everybody or can be tweaked sort of with minimal effort, or to solve gnarly problems together, then the uktre.org is the place to go. And if you're interested in the Turing's Data Safe Haven, which is a sort of cloud-based Azure hosted one, then you can go to that rather longer address. So in terms of sort of question, feel free to ask any questions that you'd like. But I'd love it if some of you were able to maybe reflect on these two questions in this discussion, or sort of when you get home to your organizations after this workshop, drop us a line and we can sort of pick up that discussion more one-to-one.
Sadaf, you want?
I can get it started. Thanks, Martin. I have two questions, and I was just thinking which order I should put them. I think the one that is bothering me more, I will ask that one first, and then the second one later. So you said there are two things you will investigate. One is what you call standalone tenancy, HPC or AI tenancy for TRE. And then you say another one where you will extend an existing TRE.
Yes.
I can see why they should be different, but I can also see you can have technically the same solution for both.
I agree. I think maybe one way to phrase it is, I could totally see a world where we deploy what looks like a satellite, but the only reason it's a satellite is because we're just supporting the minimum functionality inside that that's needed to leverage the sort of high performance compute, and we're keeping all the other the virtual machines, the collaboration sort of space, the code space, like separate. But turning that into a full TRE tenancy would be as simple as defining and deploying and making portable those components so that they could deploy over the Kubernetes layer. I think the key things that kind of differ are probably more on the ingress and egress and how you manage users. So if it's a fully fledged trusted research environment, then the environment at the high performance compute cluster needs to support all of those things and all of those processes administered by the client organization. But if you're just sending the job out and getting the results back, then the client organization's already got the sort of structure, the processes, and the technical persistent technical TRE in place to kind of manage those processes sort of outside of the cluster. And one of the things that we think might be a sort of strong practical consideration is sort of how long you can hold what could be quite contested, expensive resources, like a 4 GPU sort of high performance compute node, when what you're trying to do is the review of the data to see if you can egress it, for example. So I think this is all stuff to come out in conversation, both within the project, with DARE as a whole, and those other projects I talked about, and this wider community, including this one here.
Yeah, because in my mind, and again, it's an oversimplification, and we have to do the work. I thought with this separation of concern between infra and platform, if you are the platform, TRE platform operator, it's your business kind of thing. I don't need to
totally,
know.
Right.
Yeah. So the second question which I have, which is like you have the slide also out there. So because we are here for this Federation Network Plus event, is there an activity or project, maybe I'm jumping ahead and John will stop me, it's more about information governance federation, because whenever I think about doing something bilateral or other thing for setting up a contract, it just scares me a lot. So could you imagine a scenario where and the work needs to be done and could be one of those projects we sort of consider is you have some information governance. How do you federate in a maybe, let's call it, not very heavy-handed way, where we spend a lot of our lives and time to just go through up and down in our legal organizational setup.
Yeah, so I'm hoping that this is where some of the work that Sartra's doing to go one level down in terms of describing sort of what features of a trusted research environment and a governance process sort of satisfy the high level sort of what does a TRE need to do. So that their project, standard architecture of TREs, there's like, I think there's quite an alignment there, and I think the goal would be to say, look, here is a standard set of assertions, of promises you can make as a host, and if you are making those promises and we're confident in those promises, which might be through the fact that they are part of your ISO 27001 submission, or that you've sort of included them in your cyber assessment framework evaluation, or your data security protection toolkit evaluation, or the Sartre evaluation, then those are the things that you need to be able to do, provide that strongly isolated tenancy and a mechanism for somebody to configure that and deploy things into it. And as long as you're doing that, then for us, it's saying, well, those are it's like the Microsoft standard clauses to handle GDPR, with data moving to the US sort of back in the day or something else like that. So rather than be bilateral, it's that any HPC environment can see a very clearly defined sort of fixed thing that if they do that, and they might technically do that in different ways, then they will be able to provide that service, and the information governance, the decision then on whether someone is comfortable extending their governance, isn't, am I comfortable with those folk? It's, am I happy that they are providing that, like, standard hosting service? And so we decouple it from being two different, from every pair of organizations to being, there's a kind of, almost like a kind of legal API, the host is making some promises in their terms, or their the document where they describe or provide their security sort of assurances, and then the organization is deciding, do I know and am I comfortable in extending my governance and configuring one of these things if one is made available? And then that should be a decision they can make against someone's providing those standard assurances and standard technical sort of approaches for me to kind of do that isolation and deploy resources. And they can make that decision once, and then for minimal additional effort that probably then ends up being about the specific implementations, they can, we're going to try and abstract that away as much as possible. And I think this, in terms of places to collaborate with the wider community and where we're thinking about federation, not just in the trusted research environment context, I think there's a few places where we could do, we would really benefit from coming together and doing this work in a broader context, because it's not just about trusted research environments. So one is, can you do that? Let's remove it from being a lot of bilateral agreements and make it, someone is making some standard, I will support this type of federation, and someone else can then make a decision to be happy with that or not. And I think for the technical stuff, there's also some really interesting convergence between the type of isolation and features you might want to need to provide these strong isolation guarantees, but the concern is from the client, if you like, I'm going to put my data there and I want to know that no one else can see it. But there's been a lot of talk in the environments we've been in around clusters supporting a sort of bring your own workflow or bring your own container type model. And I think in that world, the host environment has a similar concern to say, if this thing turns out to be like wildly unmanaged code or somehow insecure, can I bound the kind of blast radius of that going wrong just to that client and not have it affect all the other clients on my cluster? And those feel like they're pointing in the same direction. And when we talk about this possible solutions, people talk about sort of multi-tenancy at the infrastructure level, and talk about, supporting containers, but where you're spinning them up as ephemeral kind of resources and things. So I feel that there's some rich collaboration opportunities there, where the problem space is much wider than this trusted research environment sort of model, and is about sort of how you maybe allow people to have more control over sort of how they use those resources. So I don't know if that answers your question, but I feel those are some areas where we'd certainly be interested in having conversations and potentially sort of looking to, apply for some.
That is good. I think there are more questions. I see the beginning of a few projects.
Has the second row over there first.
Thanks. Hi, Martin, it's Chris.
Hi, Chris.
Thanks for that talk. Really interesting. I was like, you've mentioned Sartre, and obviously we've worked on Sartre, so obviously this is very compatible with that. I was wondering about the teleport model that was also one of the DARE projects. How do you see Fridge comparing with teleport? Because teleport tried to deal with the governance model as well, kind of similarly, but also somewhat different. Do you think they're different or the same as or related in Fridge?
Yes, so I don't have full insight into kind of where teleport ended up, but I think the idea was that you could sort of deploy a TRE within a TRE. And I think we'd sort of see this as similar, but maybe with a simpler set of constraints around what the host TRE is sort of promising to provide. But when we were first talking about this, I went along to maybe you can sort of give an insight into that. There was two approaches, I think, that are being looked at in the sort of federation strand of the core components, tree evolution sort of work. And when I was first looking at this, it sounded very much like we were a slightly third thing, but I wonder if we're actually much more about, like it feels like we're actually quite aligned to one of those. And I'm sorry, I don't have the details at the top of my tongue. But
all right. I think
there's this thing. There's one, I think, where you're saying, I want to send data out to a bunch of places, have it do some compute and come back. And there's another one that says, I would like to be a parent TRE and sort of, I can't remember the other one. Can you?
Yeah, you're right. The teleport one was a TRE within a TRE, so that you're kind of sharing the governance. I think this potentially is a third way, and I think it'd be worth. I mean, we're going to be discussing this next week, right? So,
but I think that the second thing of where we're just sending jobs out feels very much like the federation model, where you're saying, I want to send my compute somewhere else and get the results back, which is, I think, one of the other strands or models being looked at. So it really does feel like either we're very well aligned, depending on the choices we make, we're either very aligned to one of the things existing under consideration, or we're close enough to figure out whether we're really different or just trying to do the same thing in a different way and should figure it out together.
I think it's the HPC angle, which is different here than I think previous projects have done. But anyway, I think we'll discuss this next week.
I think the fact that I think the big difference with teleport is the fact that if the HPC system was already a TRE, this project wouldn't need to exist, or sort of teleport would do the job. I think the goal here is to put minimal additional requirements on the host non-TRE environment to provide, if you like, a bare bones TRE. And a kind of delegation of responsibility to the folks who are running the home TRE to then treat it as part of their own in some way. So I think that's probably the key difference.
Thank you. John?
Yeah, so that's very interesting with the idea of setting up the minimum requirements to be trustworthy. But is the audit component of that in scope of the project? Because obviously, you may trust the people, but in the end, you need to audit that somehow, whether that be they've got a certification which kind of moves away from that minimum set of requirements, because now you've got whatever. So is that part of this project to consider that issue, or is that something else?
That's exactly what I was thinking about, because that audit is quite rigid.
Yeah.
And actually most of the work, most of the heavy lifting is in getting that ISO audit. And and that's going to be very dependent on the nature of that TRE. So I don't know how you could shift in someone else's TRE within your compliance zone and have that valid. I don't see that working.
So the key thing is you as the host are not taking the responsibility for operating that TRE, and what you're saying, and this will fail if every client organization who wants to extend their governance has to come in and audit every HPC system.
Otherwise, I could be running my system in a very slipshod way. It has to be audited. You can't.
I understand. Yeah. So this is what. Well, no, hang on. Just let me finish. I think this is where relying on like existing like accreditations sort of matters. But with most of those accreditations, like they're solid, as in they do provide strong assurance that the person is doing the system is run and the governance is run in the way they say they're doing, but they don't necessarily offer this as a service. And so what we would say here is, if you're ISO 27001 accredited, for example, what you have inside your, as part of your accreditation is that you can offer this strongly isolated component where another organization can sort of configure certain sort of security properties of that and can deploy, and that you provide this common sort of infrastructure, sort of virtualized infrastructure layer inside that allows them to then deploy the things that they want inside. and they rely on that, and they don't audit that because it's included in your ISO 27001 kind of assertions, and which are audited, and then they are on the hook, and it's their ISO, or whatever their accreditation is, that is kind of handling the whole system. So Microsoft, for example, their ISO 27001 approved, they've got a whole bunch of other things, and they promise that if they make the assertion in that if you use these sort of services and configure them this way, then it is very, very difficult and unlikely, semi-impossible for, like without someone hacking the system for you to sort of go across this sort of boundary layer. And then when we deploy a TRE into that, it is on us to secure the whole of that system, and for the TRE to be certified, it's us who has to gain that certification. And as part of that, we can rely on Microsoft certification for the things we're relying on them for. And that's the kind of model we want to replicate here. We want to minimize the amount of extra stuff that needs to go into your ISO certification, or your DSPT self-evaluation, or your cyber assessment sort of like framework to kind of provide that assurance. Does that make sense? So we want to piggyback on the work that's already happening in these environments to provide accreditation. So if there was a HPC system that was operating in a way that didn't cover any of that, we would definitely find that difficult. And I think this wouldn't be enough to bridge that gap.
Okay, thanks very much.
Yeah, I guess the devil's in the detail of how you combine those two sets of constraints.
Oh, 100%. Yeah.
Because we might have constraints on the way our system works, that if we let someone bring in a TRE that works that's doing certain things, it might break the separation on our system because of site's host-specific details.
Absolutely, and that's the thing we want to work out in detail. Yeah,
you got that combinatorial element, but I certainly agree with the fact that if we can get rid of a lot of the governance side, that's where all the heavy lifting sits. So in principle, it's a super idea. It's just whether those two sets of constraints can actually
and this is the key reason why Air is a really good partner for this, because there are two different technologies, different organizations, different sort of governance that are already committed to sort of strong federation. And so it's a great place, if it's not possible across Isambard AI and Dawn,
in principle, Martin, I think it's a super idea, because the really non-scalable part of our own institutional TRE is the governance side. So if you can import that from someone else's TRE, it means it's much more scalable, because the IT side is just code. To get the rest of the TRE governance is people.
Yeah. And honestly, I think if we brought this down to have to do something slightly painful once per enthusiastic HPC cluster versus once per project per HPC cluster, then we've definitely reduced the problem by some from like n squared to n, which is a big improvement. But yeah, I think this is, if we we'll find out, and we've got time at both organizations to really get into the detail, and if we can't crack it, then it's probably not crackable. And if we can, then we'll have some estimate of how much work needs to go in at another high performance compute environment, or what the constraints are, where the really sticky points were that might not be universally solvable, and all of that will be sort of really useful. And I think part of the conversations I'd like to have with the wider group of people is what would make this particularly difficult, if we did, as we start to work out what works for Dawn and what works for Isambard AI, would that work with you? And if the answer is no, can we think about whether that's a way, could we do something different with what we're doing, with Air to make it easier for some other HPC system to put the work in, to make it a smaller burden for them to, provide an equivalent sort of service.
Right. Thank you very much, Martin. Please join